Next, we're going to learn how to graph logarithms, and I did put one of these on the final exam as well. We'll be doing a lot of graphing in the next class, logarithms included. So the graph of the log. So the graph of a logarithmic function, which we know looks like this, where b, remember, has to be positive, but it can't be 1 because a base can never be 1. If b is greater than 1, so that means 2, 3, 4, like this, log base 2 of x, for instance. So the base is bigger than 1, then the logarithmic function is increasing. And there's arrows right there. So be sure and put arrows on both ends because it does go on forever. Increasing means as you go from left to right, like you read a book, the function is going up. If the base is between, sorry, Ugh. If the base is between, oh wow, get a drink. I probably, with these bad allergies, shouldn't have my window open by my desk, right? Silly me. Okay, so if the base is between 0 and 1, let's say it's a half, then the function is decreasing. Again, we have arrows on both ends, so it looks like it disappears into the y-axis, but it actually slides right along. Remember with our exponentials how they slid right along the x-axis? Well, since this is the inverse, this one slides right along the y-axis, because remember we interchange x and y. So before we were drawing functions that slid along the x, but we're doing the inverse now, so they go right along the y. And just like exponentials, because they're inverses, they share a lot of properties. When the base is larger than 1, it was increasing. When the base was between 0 and 1, which means it's a fraction, it's decreasing. So going from left to right, it's going down. The range goes down forever and up forever, down forever, up forever, is all real numbers, negative infinity to positive infinity. The domain, though, as we slide our pencil from left to right, we see that, and we're going to learn in just a moment that this is a vertical asymptote. Remember how the exponential had a horizontal asymptote? Well, since they are inverses, this one has a vertical asymptote. All vertical lines are written x equals, and this is 0. So the vertical asymptote for both of these is x equals 0. And that's for the mother function as long as it hasn't been shifted left or right with, and remember left or right would be like if you had this, log base b x plus 1. So this would be the logarithmic mother function shifted left 1, because we always have to do the opposite of what's with the x. So as long as it's just a regular mother function without any left or right shift, they will have vertical asymptote x equals 0. And just like with the exponential that we studied yesterday, the graph gets really, 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 really close to the asymptote, but it can't cross it and it can't touch it. So it just slides right along down beside it or right up along beside it, but it can't cross it and it can never touch it. So these look like they're touching, but when we draw them by hand, we'll be more careful. So the domain can't equal 0, so we put the parenthesis to show it cannot equal 0. It can get really close to it, but it can't equal it. But then it goes right forever, right forever. So it's 0 to infinity. So it starts at not quite 0 and then goes right forever. Starts at not quite 0 and then goes right forever. So that's why that's the domain. As we just said, X equals 0 is the vertical asymptote. So let's do this, underline these important things here. Let's write increasing here because it's rising from left to right, and here it's falling, so this is a decreasing function. And remember how if there wasn't any shifting, our exponentials went through the point 0, 1? Well, guess what? Our logs are the inverse, so turn the point 0, 1 around. Our logs all go through 1, 0, as long as there hasn't been any shifting up, down, left, or right. So isn't that cool? The graphs we did yesterday went through 0, 1, but these are the inverses, so these all go through 1, 0. And that's because b to the 0th is 1. That's where it comes from. So, shall we practice on some? Yes, Miss Norris, we can hardly wait. This is exciting, like you said it would be. I'm getting delirious. I've been making videos for, let's see, 10 to 6. What is that? 10 p.m. to 6 a.m. 8 straight hours. So yes, I'm going a little bit nuts right now. But bear with me. It's the last day you have to listen to my monotone, boring voice. Okay, graph the function. Plot at least 4 points for each graph. So a log graph takes a little bit of work, not hard, but it does take a little maneuvering. So the first thing you want to do when you're getting ready to graph a log is change this to y. Then remember how I said 99% of the time you're going to change a log into an exponential, because we really don't know what to do with logs, but once we get it in exponential form, that's our familiar form. So from the first page of your notes, we learned loop and swoop. So in exponential form, the base of the log becomes the base of the exponent. We know a log is just an exponent, so y is the exponent plus our loop says y should be written next, and then we set it equal to the argument. So this is the equation we'll make our t-table for. Because this is another part of the next class where they don't let you use a calculator, so you'll have to do all the graphing by hand. You won't be able to use a graphing calculator, so you have to be able to change the log into this form because you can't type this into the calculator. So 3 to the y equals x using our loop and swoop. So here's something new and exciting. First off, we like 5 points on a graph, so I'm going to make another one. So want to hear what's new and exciting? On a log graph, or remember our exponential graph from yesterday, we wrote -2, -1, 0, 1, 2. Remember that? Well, now we're doing logs, and they're the inverses. So guess what? Our -2, -1, 0, 1, 2 go in the y column. Have you ever done a t-table and filled the y column in first? Probably not. This is the only time I can think of that I've ever done that. So it's the only time when you're graphing a log, and the reason, it's the inverse of the exponential. So if I did -2 to 2 in the x column for the exponential on yesterday's work, I have to do -2 to 2 in the y column because this is the inverse. So the only time you'll ever fill in y first is when you're graphing logs, and you do your basic table. And then to get your x, you just put these values in for y. So 3 to the -2, 3 to the -1, 3 to the 0th, 3 to the 1st, 3 to the 2nd. And we know this is 1 over 3 squared. which is 1/9. And we know this is 1 over 3 because we have to make the exponent positive. So remember how we put it under 1. Anything to the 0th, remember, is 1, not 0. 3 to the first is itself, and 3 to the second is 9. So this graph has not been shifted left or right. So it is going to have the standard asymptote. Sorry. So we have a vertical asymptote, and we label it x equals 0. So all vertical lines are labeled x equals, and this one lies right on the y-axis, so it's x equals 0. And so remember, as we're drawing our graph, we can get really, 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 really close to this, but we cannot touch it. This graph should be increasing because the base is greater than 1. So let's see. So 1/9 is 0.11111. Do you guys know that trick with 9? Anytime you have 9, you just repeat the numerator. 1/9 is 0.11111. 2/9 is 0.22222. 3/9 is 0.33333. You got it, right? So 0.1 and -2. So we're right beside 0, and we go down to -2. So just right next to that dotted line. 1/3's a little bit further out and down to -1, so it should be a little bit further to the right, but not much. 1, 0, we were told that would be on every logarithm graph that hasn't been shifted left or right. Shifting occurs when you have parentheses and add or subtract something from the x, or when you add outside, which would shift it up and down. 3 goes with 1, and 9, 6, ooh, I guess we have to make an extra line there. So 9 goes with 2. So you see the general outline of our graph. So draw a curve that goes really, 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 really close to the y-axis, but doesn't cross it. And then it comes up here and goes right forever. So is it an increasing function like we guess it would be? Yes, it is. From left to right, it's rising, going up. So let's go ahead and do domain and range. So I always put those on tests. So domain, remember domain is left to right. So it starts as 0 but never equals 0. So we put a parenthesis and it goes right forever. So that would be to infinity. The range, on the other hand, goes down forever, and this is just going to keep going slowly, slowly, slowly up forever. So the range is -infinity to +infinity. So on the test, you're going to have to be able to draw in your asymptote. You're going to have to name the domain and range. You're going to have to fill out a table and draw the graph. So you definitely want to practice on your homework so you learn how to do all this before you take your test. Okay. We might not have time to finish B, but we have 2 minutes, so let's at least go ahead and start it. Okay, so there's no shifting, so we can go ahead and do our vertical asymptote. X equals 0. And that's because nothing's added or subtracted from the x or outside, so it hasn't been shifted left, right, up, or down. So it's the mother function. This one has a base of 1/4. So we learned on the last page a base of 1/4 means it's going to be a decreasing function. So it's going to look like this. where this one was increasing going up from left to right. This one's going to be decreasing going down from left to right. So we already have an idea of what it's going to look like. We want 5 points. So add a fifth in there. And we can't fill in points until we get it in exponential form, and then we can do it from there. So our goal is to make it look like this. So in order to do that, remember we have to put our log on the other side, change that to a y. So we're going to have log base 1/4 of x equals y. So I changed that to y and I just flipped it over. So now we're ready to do